Hello and welcome to the sixth lesson in Area of Study 3. Today we're going to be having a look at lab work, and I think it's probably one of the most important lessons that you will do in this topic, simply because a large portion of what's accessible is often a lab. And so I think that this is really important that you understand, which is why I've created this whole lesson on this specific topic. So what are we going to do? So we're going to look at a few things that are Area of Study 3 specific. We're going to formulate a testable hypothesis. We're going to have an introduction to data collection. We're going to have a look at data processing. Then we're going to have a look at reporting data. How do we do it? What do we do? And then we're going to have a look at some conventions in reporting. I need an experiment. Well, you're correct. You do need an experiment. And this is just really to get you to think of one now rather than later, just in case, for instance, you don't want to be wasting time thinking of an experiment when you're supposed to be doing it. So there's a few options. You can go to your teacher and ask them to come up with one. You can ask yourself, well, what am I curious about? What am I interested about? You can do the same experiment as someone else. Some schools permit that, or you can ask past students for ideas. For our lesson, I've decided that we're going to have an experiment that tests the conservation of energy. Okay, hypothesis. Right, when you're writing a hypothesis, it has to start with the word that. And it's really important. That's just one of the, well, one conventions, but it also frames that sentence as a question, or more so a prediction. So it'll be something like, we hypothesize that, for instance, the conservation of energy will hold in our experiment. And then you go on to explain it. So yeah, write a hypothesis that begins with the word that, that you know you can test using the available equipment. And it's really important that you know that you have this equipment available to you, because if you don't, then there's not much point creating a hypothesis. Take into consideration the mathematical basis of your hypothesis so that you can test it. So I think it's really important, and assessors like it when students can provide a derivation of some type to give kind of a bit more meatiness, I suppose, to their hypothesis. Then the last point is keep it simple. The more concise and specific your hypothesis is, the easier it will be to evaluate, and that's true for anything really. The more simple it is, the easier it is to analyse. Area of Study 3 specifically gives students a lot of opportunities to experiment. So motion-based hypotheses tend to work very well, specifically, so more than, for instance, experiments that involve light or sound or heat. You can use the knowledge that you have from Area of Study 3 to formulate good hypotheses. There's a lot of formulas that you can use when deriving stuff. And if you have any questions about how to make predictions for your experiment, you can ask your teacher or myself. And for our lesson today, our hypothesis is that the spring potential energy supplied by the spring will equal the kinetic energy of the cart after it is allowed to move off. Right, collecting data. You don't have an experiment if you don't have any data. It's important to have a system in place for recording your data and ensure that this is stepped out in the method. Keep note of any anomalies that you observe while you are observing it. And often mention of those kinds of things enhances your report at the end, should you need to explain any variations between what you predicted and what you observed. Use data processing software, so use Excel, or to a lesser extent use Sheets. And things like the Vernier graphical analysis is quite useful if you're doing a bit more complicated pracs. And those can save a bit of time and make analysis a lot easier. For our experiment on the conservation of energy, we'll imagine, because I don't have it in front of me, that we have a setup that allows us to measure the displacement of the spring from rest and the time it takes for the cart to travel 1 metre. We can use a Vidmax to go through video frame by frame so that we can calculate the time that it takes to move 1 metre. And therefore we can find its velocity. From that, we can calculate the average kinetic energy from both the spring potential and the kinetic energy. From our hypothesis, we can predict that when graphed against each other, the gradient will be 1 and the y-intercept will be 0. And we'll have a look at that in a moment. So, data processing and using Excel. So set up a table that includes your raw data and any formula you need. That will be quite important because you don't want things to be messy when you're going to, I guess, do your processing. All right, here we go. So here we have an Excel spreadsheet that I've created, and I'll, I guess, go through what each of the things that I've done is, so that you'll be able to apply something similar to your own. So on the left here, I've got the trial number, so it goes up to 10 trials for each different measurement of displacement. So that's my independent variable. And as you can see, all these things will be in standard units. So displacement will be in meters, the spring constant will be in newtons per meter, mass will be in kilograms, length will be in meters, time will be in seconds, etc., etc. So what I've done here, I've set the displacement for 5 centimeters, and then later on goes up by 5 centimeter increments. So then 10 centimeters, 15 centimeters, 20 centimeters, and 25 centimeters. I've kept the mass of the cart the same at 500 grams, and I've kept the length that we measure the cart to travel at 1 meter. I have recorded here different times that it takes for the cart to travel that 1 meter, which then gives us this velocity using this formula. It's pretty straightforward. It's just going to be the length divided by the time it takes. After that, we can calculate our spring energy using half kx squared, and that is literally what I've done here. So I've got a half, then multiplied by C4 is the K value, and then D4 is the displacement, and then we square that. Further along, we have the kinematic energy or the kinetic energy, and that is going to be half mv squared, which is what we have over here. So a half by the mass by the velocity squared. Then I take an average of those 10 trials, and that gives me it gives me an average energy for those 10 trials, which I will then use for my graph sketching. I do that for each of my 5 experiments, I suppose you could call them. So there's one there, one there, one there, one there, and one there. And I do the same for the kinetic energy or kinematic energy. All right, so I've simply consolidated all of these values into that array there, and I've quite literally just graphed one against the other. So I've got kinetic energy on the left and the spring potential energy on the horizontal axes. And you'll see that I've fitted a trend line that goes through them all, and I've displayed that equation as follows. Now, the next bit is really important for your analysis, and that is this table here. It's called a Linest table because the formula that you use is, called Linest. It means something to do with a linear approximation of a curve, and that gives us a whole range of data. This is all automatic when you type in that formula. You can have a look at that formula a bit more in depth. There's some articles online, or alternatively, you can contact me and I can help you step through the process of using it. From that, I've extracted values for the gradient and y-intercept of our curve, which can be matched by looking at this over here. It just gives me more decimal places. I can keep going on for a very, very long time. As you can see there, they go on and on and on. I've also got an absolute uncertainty. Assessors love uncertainties, especially when you can talk about them, and a relative uncertainty. That's simply calculated by dividing the absolute by the value. I've got here the coefficients of correlation and determination, which tells us pretty much how well our data fits, how well our line fits the data. So a correlation of 0.99 is usually something that would be deemed as very supportive of the hypothesis, and so that's what we can take away, I guess, from this experiment. All right, now that we've had a look at that Excel file, let's have a look at how we're going to report for it. So we can use the graphs, tables and images. I don't have any images in this slideshow because I didn't get any photos of the setup because I made it up. And we can use the tables and the graphs from Excel, and they should all be in your report or presentation of some kind. Make sure you caption them for a couple of reasons. One, so that you know what each of them means. So for myself, when I did my EPI, or Extended Practical Investigation, at the end of the year, I made sure that I had lots of captions because I had 10 or 15 different tables. And two, because you want the assessor to know what the data is about. So that's really quite important if you would like to kind of understand your data in a greater depth. Conventions in reports. So there's a few things here. Let's just go through them slowly so make sure you understand. So one thing is layout. So this is kind of a list of what is often required in a proper report. Your teacher may explicitly request that you don't do some of these because it simply takes too long. So the most popular tend to be those you've heard of more. And those would, for instance, be an aim and a hypothesis, often method and results, pretty important that there are results. Often have a discussion of some kind, and then the limitations, improvements and extensions can often be included as part of that discussion or as part of a broader evaluation. So that, I guess, pretty important, and a conclusion and bibliography. They tend to be the most popular things to include. I know that for myself, I included all of these things for almost all of my reports, unless I was asked specifically not to, simply because it shows that you have an understanding of what's actually required. So I've often found that to be quite important. Formatting. So when you're writing a report, you often want to do it so it looks somewhat professional, looks like you kind of care about it. So use a consistent font, size and style, and your language should be formal, it should be academic. It shouldn't include slang or not include full stops, for instance, or just be clumsy with language in general. Try not to have any spelling mistakes. Usually that's pretty easy these days because it's spell check. And headings. Now, headings, if you do it in Microsoft Word, for instance, and Google Docs, you can make it so it automatically syncs to a contents page, which is quite useful sometimes. So make sure that you either use the inbuilt functions for headings, or that if you don't want to do that, you make them really obvious, make them larger, make them in bold, underline them, do what you need to do to make sure that they stand out from the rest of the body of text. Citations. Now, this is really important if you're doing a literature review, which is somewhat popular. Not everyone does it, but it's usually required at the end of the year and sometimes for area of study 3 pracs. So make sure that you cite in the text regularly, and make sure that you use a consistent style. It's fairly easy to link them to a bibliography using Word and Docs. So yeah, you should be able to do that. With the bibliography, again, stick to the same style as your citations, the same standard, I should say. They are different. To make sure that you know the difference between a bibliography and a citation. Just make sure that it's the same kind of thing throughout. And then finally, appendices. Now, not many people tend to have them. I did. But make sure that they're in the letter order, make sure that they are the last thing, because they are quite literally an appendix onto whatever you have. So just make sure that your teacher makes it clear to you which of these are required of the layout. Especially some teachers only require a bibliography and no citations, but you should really ensure that you are comfortable with your writing and that you're addressing the criteria. All right, so short lesson today, but it was quite important, I think. So we covered a few things. We had a look at creating your experiment, collecting and processing data, reporting data, and then we had a look at some conventions. So that's it for kind of the first section in area of study 3. Next, we'll be looking at things that are a bit more theoretical, I suppose. So we'll look at Einstein's theory of special relativity and a comparison with classical physics. Thank you for your attention. I hope that you enjoyed this lesson and found it interesting. Perhaps you learned something new, perhaps you didn't. Hopefully you did. If you want to get in touch, feel free to go to the Air Learners page at airlearners.com and you can find me on the tutors page. But for now, see ya.